Hello, my name is Ibrahim, and I'm here today with my partner Shadi. We are Group 3. For our project, we decided to take a look at the Advanced Persistent Threat number 3, also known as Gothic Panda, and analyze it. Gothic Panda is an APT created by the Chinese government targeting defense construction, technology, and transportation sectors in the United States and the United Kingdom. Later on, it shifted targets to Hong Kong-based targets. Three members of this threat actor were indicted by the United States Department of Justice in 2017 for compromising the networks of three U.S. companies. To analyze this threat actor, we will be looking at two techniques used by Gothic Panda for each of the following tactics: execution, persistence, defense evasion, privilege escalation, and credential access. These are the three techniques APT-3 uses to infiltrate the system and gain privilege. APT-3 uses 38 techniques in total. We have ran some of those techniques against a Windows 10 machine to understand what they do. To do so, we installed Atomic Red Team to run the attacks. Atomic Red Team is basically a library that consists of simple tests that any security team would be able to execute in order to test their defenses. These tests are focused, do not have many dependencies, and are defined in a structured format, making it possible for usage by an automation framework. For the first tests, we were looking at the execution tactic. We used a technique titled Command and Scripting Interpreter and ran the PowerShell technique labeled T1059.001. This technique uses PowerShell on the victim system to download and run payloads after the exploitation process. As shown in the image, Mimikatz was downloaded, which dumped credentials, and upon execution, Mimikatz dumps the details and password hashes, which are displayed on the screen. The next test we ran was from the same technique, this time using Bloodhound, which basically runs Bloodhound from the memory using download cradle. It invokes a bypass using those keys and sends an XML request. Once that is complete, it downloaded the payload called mshta-mishta.exe. It then uses a fileless script execution to run the exe file, which triggers the payload. After the exe file is run, we can see it collected information about the system, including usernames, domains, logon servers, and times, and SSIDs. It also collects password hashes. As seen here, the executable file tries to gain information regarding group sessions, trusts, local groups, and other information. Since our test machine is not under any group or forest, we get this message stating it was unable to determine the user's domain. Another test we ran for this attack tests if Mimikatz session was started successfully, which in our case it was. We get this message saying the cradle worked and successfully executed PowerShell code from a remote location. This implies that the attack was successful. We also ran a test where we checked if the psend keys command was successful, which as seen below was. Upon execution, the Mimikatz Cradlecraft psend keys test will generate automated actions which take place. The attack opens up File Explorer and dumps all the information to a notepad, after which it displays this information to us in an organized format in the command line. The last test we ran was to check if the bypass was successful. This attack invokes an app path bypass, which is based on the paths found here. It checks who executed the commands and if elevation of privilege is required, and then runs the command with the payload cmd.exe. The next technique used is the user execution technique, while we ran the malicious file technique from. This attack downloads a file to the victim machine, which, if run, activates a payload. We ran the test for this attack, but we received a message saying the host name certificate was invalid or does not match. This may be due to the attack being outdated. Moving on to the persistence tactic, we started by looking at the create account technique and running the local account T1136.001 attack. This attack creates a new user on the victim machine. Running the test, we can see it was successful and the user was created. It also tells us to run the command netuser and look for the username it created. After running netuser, we see a new user was created under default account and called T1136.001 underscore CMD, which is the technique number for this technique and shows a user was created under the command prompt. The next technique we used was scheduled task job technique. This technique uses the command prompt to spawn at .exe, which will create a scheduled task that spawns cmd.exe at a specific time. However, the at.exe command line utility used by this technique was deprecated in recent versions of Windows for SCH tasks, which is why we get the error message saying the request is not supported.
Hey guys, I'm Shadi and I'll be taking over the presentation from here. Now we're moving on to defense evasion and start by looking at the technique called process injection, in which we use the process hallowing technique using PowerShell. It creates a hollow from a PE on disk with Explorer as the parent. This technique opens the file for access and creates a section from file handle. It then opens the handle to the parent, which is Explorer, and creates a process from the section and acquires the PBI. Next, it acquires information about the victim system and allocates space for the hollow process. It then duplicates the hollow PE headers and sections .txt, .rdata, .data, .pdata, and .did and .rsource and .reload to the sponsor. Then it creates a hollow parameter and allocates memory and duplicates them to the hollow and creates the main thread. So we're moving on to masquerading. So APT3 also uses this technique called masquerading for the defense evasion tactic. We looked at the masquerade tasks or service attack. This attack creates a task named similarly to the win 32 times task using schedule tasks. Running the test to ensure it is run accurately, we see the task was created along with the time and date it is run and its status. The next tactic we'll be looking at, as stated before, is the privilege escalation tactic, and we'll start with the technique access token manipulation. For that, we will look at the attack called parent ID spoofing. This attack basically replicates how Cobalt Strike does parent process ID spoofing. It spawns iExplore.exe with its process ID, which will be displayed while the process calc.exe will be spawned, launching the calculator app. During the test, we see that iExplore.exe was launched with its process ID 10284, but the calculator app was launched instead. For the same tactic, APT3 has another technique which is called valid accounts. This technique is much easier to explain. The APT would create a new administrator account with no password and use that account to enter the system with admin privileges. Once the script was executed, we can see that the account was created and it was added to the administration group. The final tactic we tested out is credential access tactic. From that tactic, we tested the keylogging technique. This attack basically launches a payload with the purpose of capturing keystrokes. The attack starts by launching a payload called getKeystroke.ps1. Once this executable file is ran, keystrokes are captured and put into a file called key.log, after which the file is transported back to the attacker. Finally, the last technique we ran was the LSAS memory dump. In this technique, an executable file called lsas.exe is ran, and an offline credential theft attack is launched. The LSAS memory is dumped into a file called lsas_dump.dump in the temp folder by using sysinternal tool procdump. From there, the attacker can have access to all credentials available on the victim's machines. So after running all the attacks, it was time to collect the artifacts to check for the presence of the techniques run on our victim machine. Starting off with PowerShell technique, we found this log that had the path shown in the first image here, which related to GitHub's PowerShell Mafia PowerSploit. This is clear identification of malicious activity, so we took a look at the logs right after this one, and they related to Emma's gaming overlay. The next attack was malicious file. This technique used a file that goes by the name mimikatz.ps1, which was executed to run payloads as we mentioned earlier. For this attack, since it was a user execution to get initial access to the machine, we knew we were looking for some sort of compression application that would be used to deobfuscate file or information in payloads. We found the log starring the mimikatz.ps1 file, and the log right after that was the zip file called cape.zip, which we instantly knew is the file we were looking for. Now for this attack, which was the creation of local accounts, we had to find some sort of log information relating to the user T1136. We knew the user was created in the command prompt, and we see the user present using netuser, but how do we find the log relating to that as analysts? After some researching, we found that the event ID related to account management that is assigned to the creation of new users is 4720. Going through the Windows security logs on the victim machine, we found that the log that showed us account was created as well, as its domain, name, and group were all present. This allowed us to see what privileges the account was given as well. Moving on to the next attack, we found a suspicious executable file called at.exe in our dump. We decided to take a look at the logs that came after that executable, try to understand what it did. We came across many logs related to task scheduling, as the paths shown lead to task schedule.ps.dll, so we instantly knew this was related to scheduled tasks. Taking more time to look through the dump, we found this entry that mentioned Hollow Hunter. That was suspicious, and we suspected this log to be related to process hollowing. Once we confirmed that it was related back to Cape and its modules, our suspicions were confirmed, and we knew this related to process hollowing. Now, we looked deeper into the logs and found that there were many called called to schedule tasks, which is related to task schedule. Nothing seemed suspicious in the logs, but on a hunch we decided to take a look at task schedules to try to understand them better. We found a scheduled task to run every day at 11:05 precisely that was called Win32 times. Knowing that this process is not a Windows process, yet carries a name that bears a close resemblance to Windows, we looked it up and found it was a masqueraded process. Now, to find the data for PID spoofing was a bit tricky. After then running the attack, we noticed that the calculator app just showed up. We decided to look at the running processes to find out what happened, and after a closer examination, we noticed that the iExplore.exe process was running, but Internet Explorer was not active on our machine. The process ID made sense, but its presence did not. After quitting the calculator app, we noticed the process disappear. This gave us a smoking gun to identify the spoofing was occurring. Now, for the valid account technique, it was very similar to the local account. All we did was go through the Windows security logs again and look for an event ID 4720. We found the event that created our test, and we examined the account to notice that it was given administrative privileges. Now finally, for the LSAS memory dump, we found an executable file in our dump called lsas.exe. That was suspicious, and what was more suspicious is that the log right after that showed presence of a security log. The entry right after contained a path leading to lsas_setup.log, which after some research we found related to a memory dump attack. Now this was long yet interesting activity that gave us the knowledge to understand what tactics and techniques advanced persistent threats use to infiltrate the machine and how to identify them. Thank you for listening and sharing with us in our journey.